So by definite integrals, I mean integration with limits, which in its generic form looks something like this, where a is the lower limit, b is the upper limit, and f dash x is the gradient, which we have to integrate. Now, how do we solve this? The generic formula is upper limit minus lower limit, but this is not going to be sufficient for you to understand. So first of all, start off with integration of f dash x. Once integrated, this is how we write down the limits once again, and finally apply the limits. That is, substitute the limits instead of x. So first of all, the upper limit and then the lower limit. So we end up with f of b minus f of a. And the answer is going to be the answer, final solution of our definite integral. So you should notice that when we integrated this thing, we did add a c. And when we applied the limits, we end up with something like this. The upper limit minus the lower limit. And notice that c cancels off. Therefore, we see that there is no need to add c when solving definite integrals. Moving on, let's take a few examples. The first being, let's say, integration of integration of 10x with limits phi and 2. The first step is to integrate 10x, and we end up with pi x squared. The limits are phi and 2. So start off with substituting phi and subtract the lower limit, that is 2. Let's speed things up a bit, and we have 125 minus 20, that is 105. So our final answer is 105. Moving on, our second example. Let's say the limits are 10 and 2, and we have something which looks like this. We have a square root in the denominator. Let's bring the denominator to the numerator first. So we have 2x plus 5 to the power negative half. Integrate this thing. That would look something like 2x plus 5, add 1 to the power, bring the power down, and multiplied by the differential of the bracket. 2 and 2 cancel out, and we are left with 2x plus 5. The limits are 10 and 2. So first of all, substitute the upper limit and then substitute the lower limit. So we have square root of 25 minus the square root of 9. 5 minus 3, and we end up to have a 2. And this was our second and our last example, and this is where we wrap up definite integrals. First of all, we understood it generically and why there's no need to add c, and then we had two examples. Hope this suffices.